Hi everyone, so today we're studying about sphingomyelin, its synthesis and its degradation. So sphingomyelin is basically a sphingosine-based phospholipid. What does this mean? I told you phospholipids have glycerophospholipid and sphingophospholipid. So sphingophospholipid's example was sphingomyelin. Now it consists of sphingosine as its alcohol, right? Now what happens initially is you have palmitoyl-CoA and serine. Palmitoyl-CoA and serine, they condense together by releasing carbon dioxide and CoA, and they need NADPH. So this means if there is an NADPH, this means reduction is happening, right? So reduction happens and decarboxylation happens and you get sphingosine. Sphingosine, this sounds quite tricky as a name, but if you focus at the structure, you'll notice it has double alcohol. So it's dihydrosphingosine, and sphingosine is the name of the alcohol. So the second name isn't that hard. So dihydrosphingosine. Dihydrosphingosine, also known as sphingosine. How was it formed? By palmitoyl-CoA and serine decarboxylation, and the CoA also got removed. Now you got sphingosine, dihydrosphingosine. Now in this sphingosine, one fatty acyl CoA got added. Obviously CoA got removed, but fatty acyl got added. And also there was desaturation, a double bond was introduced, and you got ceramide. So from sphingosine, we made ceramide. Now in this ceramide gets phosphatidylcholine added. So phosphatidylcholine gets added in this ceramide, and you get your sphingomyelin. Now, exactly what part of this, um, let's say ceramide, exactly what part of this gets actually phosphatidylcholine, exactly what part of this phosphatidylcholine gets added? Phosphorylcholine gets added and diacylglycerol is released, right? So we can name ceramide as a precursor of sphingomyelin. So exactly what happens, let's recall. First of all, palmitoyl-CoA and serine, they come together and they form the dihydrosphingosine, also known as sphingosine. This sphingosine, it got converted to ceramide because fatty acyl-CoA got added, and then you have after ceramide, it, it is a precursor for sphingomyelin. So directly we get our sphingomyelin. Ceramide gets converted to sphingomyelin by the addition of phosphatidylcholine, which is our PC, also known as lecithin. So you need lecithin here, and it gets added to ceramide, and we get our phosphorylcholine. Now there is this clinical here that says ceramides, they play a key role in maintaining the skin's water permeability barrier. Ceramides play a key role in maintaining the skin's water permeability barrier. Decreased ceramide levels are associated with a number of skin diseases. So due to any reason, if ceramide is low, there'll be a lot of skin diseases. So again, let's recall. First of all, palmitoyl-CoA and serine, they come together and they form sphingosine. Sphingosine, which is also dihydrosphingosine, it gets converted to ceramide, and that ceramide gets converted to sphingomyelin by the addition of phosphatidylcholine, right? And if there is any sort of deficiency of ceramide, or ceramide is not being made, this means that there will be skin diseases because ceramide maintains the water permeability barrier of the skin. Now, when you talk about degradation, now for degradation, what happens is that this sphingomyelin, obviously it has to break down. So first of all, we have this enzyme called sphingomyelinase that is going to break down. Sphingomyelinase is a lysosomal enzyme that removes phosphorylcholine. So it's going to remove this phosphorylcholine, and it's going to leave behind what exactly? It's going to leave behind ceramide. So sphingomyelin to ceramide, this is done by sphingomyelinase myelinase. So sphingomyelinase, oh my god, the handwriting is so illegible. Actually, let me just write it like this. Sphingomyelinase. So sphingomyelinase basically breaks down sphingomyelin into your ceramide and it leaves behind phosphorylcholine. Now this ceramide, it's broken down by ceramidase, and this gets broken down into what exactly? A free fatty acid and sphingosine. So ceramide is broken down by ceramidase into free fatty acid, and our alcohol sphingosine, it's separated. So if you look at the structure, so this is sphingosine, so sphingosine gets separated, and also the free fatty acid which was added, fatty acyl CoA, that's also separated. So we get sphingosine and for free fatty acids. So this is very simple. The breakdown and also the synthesis. So we already know the synthesis. What about breakdown? You have sphingomyelinase, which converts sphingomyelin to ceramide by removing phosphorylcholine, and then the ceramide, in the presence of ceramidase, gets converted to free fatty acid and sphingosine, right, which is the alcohol. Now, what happens is that Niemann-Pick is one of the diseases which are caused because of deficiency of sphingomyelinase. What is the disease? Niemann-Pick. Now you have two types of Niemann-Pick. One is type A and the other is type B. When you talk about type A, over here there are very few lesser chances of that kid or that baby surviving, but in this a person can survive, the chances are a little more. Now what exactly happens is that Niemann-Pick, it's an autosomal recessive disorder which is caused by the inability to degrade sphingomyelin. So we cannot degrade sphingomyelin. Why is it so? Because of the deficiency of sphingomyelinase. So if anyone asks you about Niemann-Pick, so it's caused by the deficiency of sphingomyelinase. And then what happens exactly is that sphingomyelin starts accumulating. Now in severe infantile form, type A is the severe infantile form where um, the results are seen in liver and spleen because that's the primary site of lipid deposition. There we can see hepatosplenomegaly, right? And because what happens that a lot of this lipid, sphingomyelin, it starts accumulating in the liver and spleen, resulting in hepatosplenomegaly, and these lipids, they cannot be degraded. And the other thing is that the macrophages of the reticuloendothelial system, they also become engorged with sphingomyelin. So when you look at them from a microscope, their histological picture, it shows a very foamy histological appearance of the reticuloendothelial, the macrophages of the reticuloendothelial cells. So again, what was I saying? Type A is a severe infantile form. Obviously, we have sphingomyelinase deficiency, but what happens is that this starts accumulating, the sphingomyelin, it starts accumulating in liver and spleen, resulting in hepatosplenomegaly. And also the second thing is in the macrophages of reticuloendothelial cells, also it starts accumulating and the histological appearance is foamy. Now moving on, if we talk about the infants with this lysosomal storage disease, they experience a rapid and progressive neurodegeneration. So those patients or those kids, they experience neurodegeneration as a result of deposition of sphingomyelin in their central nervous system. And also they have a cherry red spot in the macula. So they also have a cherry red spot in, actually I should note this down. So first of all, these patients, they are prone to experiencing neurodegeneration, and then the second thing is the cherry red macula, which is a cherry red spot, a cherry red macula, which is a cherry red spot on their macula. And then also there's edema in retinal ganglion cells, right? Now, why is the cherry red macula, you may be wondering, because of lipid deposition, and also edema in the retinal ganglions is because of the sphingomyelin deposition. Now, these infants die usually early in their childhood. Whereas if you talk about type B, this is a less severe variant, even though it's still severe, but it's less severe. And what happens here is that it has a later age of onset and a longer survival time because there's no damage to the neural tissue, so there's no neurodegeneration. But obviously the lungs, they're still affected, the spleen is affected, the liver is affected, and even the bone marrow, that's also affected in this. That results in a chronic form of the disease. So this results in a lesser severe but chronic form of the disease, and it's not like assigned to a certain ethnicity that people of certain ethnicity can develop this disease. It can be in any person belonging to any race. So yes, this is about Niemann-Pick type A and B and the synthesis and degeneration.